welcome back to my another video. Myself Darshanar. This is the YouTube channel called Darshanar the Edu. In this video, we are gonna learn about the deterministic finite state machine, that is the DFSM. Introduction to deterministic finite state machine. Deterministic finite state machine is a mathematical model of a computation. It consists of set of states, a set of input symbols, a transition function, and the start state. The dfsm processes the input to determine whether the given string is accepted or rejected. In this, we will see how a ATM or any traffic light signal is accepted or not, if the given state is accepted or not. In the further model, we're gonna learn about this. Definition and the components of deterministic finite state machine. A deterministic finite state machine is a mathematical model used to design and understand the algorithm. It consists of finite sets of states, a finite sets of input symbols, a transaction function, and an initial state. The transaction function maps the state and an input symbol to the next state. This deterministic nature makes it predictable and well defined. Now we are going to see the states and the transitions in a deterministic finite state machine. State represents the condition or the situation in the system. Transition signifies the change from one system to another based on input. Deterministic, each state has an unique transition for each input. These are the states represented in the deterministic finite state machine. Now we'll see the difference of deterministic and non-deterministic finite state machine. In deterministic finite state machine, the deterministic machine has a single possible transition for each symbol. They are easy to design and understand. Whereas in non-deterministic finite state machine, non-deterministic machines can have a multiple possible transitions for each symbol. They are more complex and powerful to understand. Now let's see the example of deterministic finite state machine. In this, we're gonna see the examples of deterministic finite state machine, that are vending machine, traffic light control, and the elevator control. In this, they are all the real world application used. A vending machine is a classical example of deterministic finite state machine, with a state of accepting the money, selecting the product, and dispensing the item. In the traffic light control, the control system of the traffic light is a real-world application of a deterministic finite state machine, with the states for green, yellow, and the red lights. In the elevator control, an elevator control system is another example of the deterministic finite state machine, with the states for stop, move up, and move down. These are the real-world examples of deterministic finite state machine. Applications of deterministic finite state machine. The first application of the deterministic finite state machine is the software engineering, used in the lexer parsers and the code analyzer to process and validate code syntax. Network protocols implement a protocol logic for data packets, routing, and error handling in the network communication. Automated control system applied in smart grid, traffic control, and industrial automation for efficient decision making. And pattern recognition, recognizing the pattern in image and signals used in the image processing and signal analyzing. These are the applications of deterministic finite state machine. The advantages and the limitations of deterministic finite state machine. The advantages are deterministic finite state machines are easier to design and understand due to their clear state transition, and they offer a predictable behavior and are more suitable for real-time application. Limitations: they may require a large number of states to model complex systems, leading to increased complexity. Modifying the transitions may require a significant redesign and impacting the system flexibility. Now, let's see the designing a deterministic finite state machine. Identify the system states, determine all the possible states the system can be in, define the transition, specifying the condition for trans transition between the states, establishing initial state, designated the start state of the machine. Implementing a deterministic finite state machine. Im- Implementing a deterministic finite state machine involves defining the state transitions and the initial state. The transition function and the action output need to be specified for each state transition. The implementation also involves designing the data structure and logic to execute the transition. Now we have come to the last part of our video, that is the conclusion about the deterministic finite state machine. Understanding the DFA design, that is the clear structure and defined transition, implementing in the softwares like efficient handling of complex logic. Real-world applications are enhancing the security and validation process. As we conclude, it's evident that deterministic finite state machine provides a structured approach to modeling systems, from clear design principle to the practical software implementation and the real-world application. The benefits of DFSA are far-reaching. Understanding this key takeaway, what enables the seamless integration of DFSA in various domains.